Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about call and return instruction in the 8051 microcontrollers. See, whenever we have some subroutines, so we need to use this call. So what is the need for subroutine? Whenever we have a set of programs that will be repeated multiple times, so that can be put it into a single position, single location, and whenever it required, we can call it. So this is the basic concept of call. Whenever we required, we can call that program. Again, after completion, we can return to the main programs. So this is the call and return of basic operations. Look at this. So it is called as a similar to jump, but it have the return back. So normally if you jump from one location to another location, we never come back to main location. But here not like that. So here whenever we are jumping from any location, after completing that particular program, again we return back to the where we called that. So for example, if we call from 4000, currently I am executing a 4000 location, I am calling a 5000 location program. So after completing that 5000 location programs, we have one instruction called return. So once if I get that return instruction, again I come back to the 4000 location where I am executing previous programs. So after that, the main program will be executed. So the main reason for call program means, for example, if you, some programs are repeated mainly multiple places, so unnecessarily it makes the memory occupancy. So to avoid that memory occupancy, we can use this subroutine. So once if we use the subroutine, whenever we require, we can simply call that instruction and we can use that. So once if the call instruction is used, what happens? Actual current program counter value will be pushed in a stack, because we need to return back now. So for return back, where we need to return back? So the current program counter value only we need to return back. So that current program counter value will be pushed into stack. So for example, if you inside a one loop, again another loop we are calling, again data will be pushed. So stack is a last in first out concept. So if you jumping a multiple branching or a multiple call function, it won't affect the final results. Look at this. This is, we have two types. One is A call and another is L call. So A call is the absolute call. Here we use this 11-bit address. So we already learned these previous classes. That is, we use this 8-bit plus the page memory concepts. So within the 2 kilobyte only we can able to take a call functions. Look at this. This call function. So only this within this 11-bit we can take a subroutine programs. So what happens once if you have an A call? So the program counter value will be pushed into stack. Again, this program counter will be loaded with this address, 11-bit address. So what happens? Actual program counter will be modified to some other location. What happens? Actually, whatever the content present in program counter, that corresponding location program only executed. Here when we have changed that location, automatically that location content will be started executing. So once if we have a return, it will be come back to the main program. We retrieve the data from a stack and that will be restored to the program counter. Look at this another option, L call. This is long call. So long call, it uses the 16-bit address. So due to 16-bit address, entire 64 kilobyte can be jumped. So the operation is remaining will be same. So the program counter value that will be moved to stack. Again the program counter will be loaded with this new address, 16-bit address. So after completing this, the data will be retrieved from a stack and that will be restored to the program counter. So this is the actual operation happens in the call. So whenever we have a call, we should have a return instruction, because only if the detects the return instruction, it come back to the main programs. Look at this next instruction. This is the return instruction. So return is similar to the jump, but it return instruction pops the program counter value from a stack and restore that value. It comes for a main location. So instruction is very simple. We have used RET only. So once if you put this, it take last data in the stack and restore to the program counter. So actually what happens? So where it will be called, for example, when you are executing a 4051 location, it will be called means this 4051 will be stored in the program counter. After completing that subroutine, it come back to the 4015. the same thing will be happen. So this call and return will be combinedly used for getting a subroutine. So without call we cannot get an instruction. So jump is similar to call, but it won't return back. But if you use this call instruction, so after completing the subroutine program, again we can come for a main programs. Thank you.